Download this code from codegive.com, link in the description below. Logic App HTTP Post Request Timeout within an Until Container, a comprehensive tutorial. This tutorial delves into handling HTTP post request timeouts within an until loop in Azure Logic Apps. Timeouts are crucial for preventing your Logic app from hanging indefinitely when a downstream system is unresponsive. We'll explore the problem, various solutions, and best practices, illustrated with code examples. Understanding the problem. The until loop in Logic app allows you to repeatedly execute actions until a specific condition is met. Often, this involves making HTTP post requests to external APIs or services. If the external system experiences a delay or becomes unavailable, your post request can hang, potentially stalling the entire Logic app execution. This is where timeout management becomes essential. Naive approach, and why it's flawed. A common, but incorrect, approach is to rely solely on the built-in timeout settings of the HTTP connector. While the connector has a timeout setting, it only applies to a single HTTP request. If that request times out, the until loop will typically stop. However, if the condition for the until loop isn't met, due to the failure of the HTTP request, it will either not retry or retry indefinitely until the Logic app times out completely, which might take very long depending on its configuration. Effective solutions *. We need a mechanism to manage timeouts at the until loop level, allowing for controlled retries and graceful handling of failures. Here are two effective strategies. 1. Using a scope with a timeout policy and retry logic ***. This approach encapsulates the HTTP post request within a scope action. We apply a timeout policy to the scope, and use a retry mechanism to handle transient failures. Explanation ***. Scope _1 * encloses the HTTP request and condition check. The timeout property sets a 10-second limit for the entire scope. If the scope doesn't complete within 10 seconds, it will fail. *HTTP _1 * the HTTP post request. *retry policy * configures 3 retries with a 1-second interval between attempts. This handles transient network issues. Adjust the count and interval according to your needs. Condition check * checks the response of the HTTP request to verify if it was successful. You might need to adjust the condition depending on your API's response structure. If it's successful, the condition met variable is set to true. Until *1 the loop continues until condition met becomes true. 2. Using a timer and a variable for timeout ***. This approach is more flexible but requires more manual coding. Explanation ***. Initialize _variable _1 * stores the current UTC time in the start time variable. Until *1 the loop continues until either the elapsed time since start time exceeds 10 seconds, 6,100 nanosecond ticks. The HTTP request is successful, based on your API's response. HTTP _1 * the HTTP post request. No explicit retry policy is included here. You could add one externally to this action if needed. Best practices ***. Exponential backoff * for retry policies, use an exponential backoff strategy. This avoids overwhelming the failing system with repeated requests. Error handling * implement comprehensive error handling. Log errors, potentially send notifications, and gracefully handle failures. Circuit breaker * for highly critical scenarios, consider implementing a circuit breaker pattern to prevent repeated attempts to a consistently failing service. This usually requires external components or custom connectors. Appropriate timeout values. Choose timeout values appropriate for your system. Start with a relatively short timeout and increase it only if necessary. Monitoring. Monitor your logic app executions closely to identify and address potential timeout issues proactively. Choosing the right approach. The scope with retry policy method, first example, is generally preferred for its simplicity and built-in retry mechanism. The timer approach, second example, offers more granular control but requires more manual management. Choose the method that best suits your needs and complexity requirements. Remember to replace placeholders like https://yourapiendpoint.com/data and success with your actual values. Thoroughly test your logic app with various scenarios, including simulated delays and failures, to ensure robustness.